We're going to take a second look at partial fraction decompositions. This time, we're going to be looking at some denominators that have factors that are not just linear. So we'll see some that have quadratic factors and how to work with those. We're going to learn a second technique for identifying the values that we need for our numerators. Let's go ahead and dive in. I want to start with putting together some templates. So we know that whenever we have a linear denominator, so that would be degree 1, we need a degree less in the numerator. So degree 0 would be some kind of a constant. And whenever we have a degree 2, x squared plus something minus something. So whenever we've got a degree 2, we need a linear numerator. Linear would be mx plus b, but we're going to think of that as bx plus c, or whatever letters we happen to be on. So in this first one, it's already factored for us. My factors are irreducible. I can't factor them any further. So I'm ready to set up the template. I've got a linear denominator, x minus 3. So that needs a constant numerator, a, plus that x squared is plus 4. That's the sum of squares, can't be factored further. So that one needs a linear, so bx plus c. The next one, we need to factor this guy. So if I put this into two factors here, two binomials, 12, let's go ahead and try 3x and 4x. And then 7 would be 7 times 1, but I need 31 in the middle. So I'm going to put the 7 with a 4. That gives me 28. And then 1 with the 3, 28 plus 3 is 31. Perfect. Both of those negative give me a negative in the middle and 7 on the end. These are both linear. So as I put this template together, I get 3x minus 7 plus 4x minus 1. Since they're both linear, I'm going to give it constant numerators, capital A and capital B. In the next one, I've got an irreducible quadratic, but I also have this x squared. The x squared we think of as being able to be factored further, x times x. So as we set this one up, it would be x plus x, but it doesn't make sense to have the same denominator in two different fractions. So we're going to use its multiplicity and put power 2 in the second one. And then x squared plus 10. The key here is to think of that factor x as a linear factor, just like we've got it over here. Multiplicity doesn't affect the numerator. So for the first one over x, I would definitely need a constant there, a. X, even though it's squared, that was multiplicity, so I'm going to give myself a constant b in the numerator. X squared plus 10 is degree 2, so this one's going to be linear, cx plus d. Okay, and this last one already factored for us, which is great. X plus 3, that one's linear, so we need a constant numerator. X squared plus 16, that one can't be factored further. It's degree 2, so we need a bx plus c. Okay, just really great practice there. We are going to need another technique if we can't zero everything out. So remember, one of our techniques is to use zeros. So let's go ahead and start with the factorization of this denominator. So we still have the x squared plus 68. My denominator has a common x squared in it. So I'm going to factor out the x squared. X cubed divided by x squared is x. X squared divided by x squared is 1. This gives me two different factors, but this guy can be factored further as x times x. So to set my template up, I get 1x, 2 x's, but I'm going to use my multiplicity there, and then finally an x plus 1. So I need an a. X squared, it still is linear, so I need a b there. That's the only tricky part about these degree 2s, is when you have an x all by itself. Next one's definitely linear, so that one's going to be a c. Let's go ahead and go through and multiply by any missing factors. We are building ourselves up to my original denominator. So a over x, it's missing one of the x's, and it's missing an x plus 1. So I'm trying to cover all of, you can also think of it as those, all of those. X squared, which is the denominator of b, it's got the first x squared, but it's missing the x plus 1. And then finally the c, it's got the x plus 1, but it's missing the x squared. Remember, at this point, you can just compare the numerators. You know the denominators are going to match, assuming you did all this correctly. So my numerator is x squared plus 68 is equal to ax x plus 1 plus b x plus 1 plus c x squared. This is going to give us a couple of different zeros. So we're going to go through the zero process first and see if we're able to find all of our letters A, B, and C. To make this first term 0, x could be 0 or -1. Actually, let me write those up above so I've got more room. There we go. Okay, so it could be 0 or -1. -1 here again, 0 here again. So as I go through and start to plug these into our numerators, I'm going to go ahead and put -1 in for x. I get -1 squared plus 68 is equal to a times -1, -1 plus 1, that goes away, plus b, -1 plus 1, that goes away, plus c times -1 squared, that one stays. -1 squared, this is 1 plus 68, that's 69, equals c. So I've got c already. Let me go ahead and put that up in our answer. So c is 69. So 69 over x plus 1. So we've got this one done. Let's go ahead and do another one. The other one that we had was 0. There were only 2. So I finished -1. I'm ready to compare 0. Now I'll put 0 through here. So 0, starting with, let me put a yellow box around this that we're using here. We're going to go ahead and start on the left-hand side there. So we get 0 squared plus 68 is equal to a times 0. That one's going to go away, right? Plus 1. That one's gone. Plus b times x plus 1, but x is 0. 0 plus 1 plus c times 0 squared. That one goes away as well. So this one gives us 68 equals b. Okay, I've got one left to go. So 68 is equal to b. So plus 68 over x squared. I've got one left to go. I don't have a way of getting at a. And that's because I have both the x that zeroes out with 0 and then x plus 1 that zeroes out with -1. So I need to use my second technique. My second technique is comparing coefficients. To compare coefficients, we need an additional algebraic step. Let me go ahead and just give myself some room here. I'm going to go ahead and take what I've got in yellow. We can actually put in our A, B, and C, not our A, right? But we can put in our B and C. So let's go ahead and do that. And then we're also going to multiply this guy out. So as I'm comparing coefficients here, I've got x squared plus 68. I don't know what A is, but I'm going to go ahead and distribute my AX. So AX times X is AX squared. AX times 1 is plus AX. B, I can replace B with 68. So I'm going to go ahead and distribute that 68 through. 68 times x, so I get 68x plus 68. I forgot my x there. And then finally the c, let's go ahead and replace the c, I'm going to write it in red, with 69. So I get 69x squared. Notice how I'm lining up my like terms. 69x squared. I need to compare coefficients to get here. The only way I'm going to be able to solve for A is if I compare coefficients that has an A in it. When you're comparing coefficients, this is the formula we're using now. It's the same as this one, just multiplied out with our B and C in there. We want to go ahead and grab the coefficients for each degree. I'm going to go ahead and start with my x squareds. So for x squared, we have 1 on the left, so 1x squared, and I've got an ax squared and a 69x squared. I'm just taking their coefficients. So if I have 1 on the left and I've got a plus 69 on the right, those two had better equal. A plus 69. So if I subtract 69, I've got my answer. So negative 68 is equal to A. Okay, don't worry, we're going to use this technique again, so you will get some more practice with it. So negative 68 over, this was A, so over X, put a plus sign in between everybody, and there we go. Okay, so that second technique, this new technique right here, comparing coefficients. We multiply out and then compare term by term. Okay, let's go ahead and do this next one. This next one is already multiplied out for us, so I can go ahead and set up the template. We've got x squared, so that's going to be x plus x, but I'm going to use multiplicity, a and b here. And then this one's really similar, x squared plus 10. So we're going to end up with x squared plus 10, so that's going to be cx plus d. I'm going to go ahead and multiply in any factor that's missing from my denominator here. So a needs to be multiplied by another x. That gets us to our x squared. And then it's also missing the x squared plus 10. B is missing just the x squared plus 10. C is missing the x squared. I need to multiply those out, but I'm actually going to write my next step because everything's a little bit of a mess. So my numerators, my original numerator was 4. The numerators that I have here are ax, x squared plus 10. So I'm not going to multiply it out. I will do that in the next step. Plus b, x squared plus 10, plus cx plus d, x squared. We're going to compare coefficients. I could at this point use zeroing out, and I could let x equal 0. That comes into play here and here, but it's only going to find me one of my numbers, and I'm going to have to multiply this out anyway. So instead, I'm going to go to coefficients. So I'm going to end up multiplying this out and then comparing term by term. Let's go ahead and start by distributing. So I'm going to distribute the ax here, the b here, and the x squared here. Okay, nothing to do on this side, so still a 4 there. Ax times x squared, so I get ax cubed plus 10ax, plus moving on to the second term, bx squared plus 10b, plus distribute that x squared on the right, I get cx cubed plus d x squared. Now I'm ready to compare coefficients. And I noticed that I've got as my highest degree x cubes, so I need to compare x cubes, x squareds, x's, and constants. So let's go ahead and go through our comparison. I'm going to grab a different color. I'm going to start with green. X cubed is our highest degree. There aren't any on this side, so there's 0 x cubed on that side. But we've got a on this side and c. So for my x cubes, I have 0 on the left, but I have a plus c on the right. Okay, doesn't get me to an answer yet. So let's go ahead and move down to our squareds. I'll do purple this time. So x squared. X squared, again, none on, I should just put 0. So 0 on the left. So as I'm comparing x squared, 0 on the left is equal to, on the right, I have b plus d. B plus d. Okay, another color, I'll do brown. Now we want to compare our x's. Again, there are 0 x's on the left. On the right, we have 10ax. I think that's it. 10a of those x's. So I can solve this right away. I can divide both sides by 10. And I know that a is equal to 0. If a is equal to 0, that means I have this one too. It's like a puzzle, right? So if I go back up to that one, let me finish that one now. 0 equals 0 plus c. So c is also equal to 0. Okay, now I've got b and d left. So I've gone through everything except for my constants, so my numbers. Let me just grab one more color. What color haven't I used? I'll do red. So now I'm ready just for my constants. I do have a constant on the left. So 4 is equal to constants 10b. Right? There aren't any other, just double checking. Yep, 10b. So this tells me that b is equal to 4 divided by 10. And I have d as well. So if I put this in for 0 equals b plus d, 0 equals 4/10 plus d. Oh, this is a plus sign. Negative 4/10 equals d. So I have all of my values. There is not an a. Go ahead and put this all together. So I'm back at my template here. There is not an a term, but there is a b term, and that has a 4/10 up on top. So I have 4/10 x squared plus c is 0, d negative 4/10 over x squared plus 10. You can also move the 10 to the denominator, and you could write this as, let me give myself a little more room. You could also write this as 4 over 10x squared minus 4 over 10x squared plus 10. Okay, there's that second one. That one was messy. Number 3. Okay, we've got just one left here. This one's already been factored for us. Both of these are irreducible, so I'm ready to go ahead and put this into my template. X plus 3, that one's linear, so I need an A, plus x squared plus 16, that one's degree 2, so I need a bx plus c. I'm going to go ahead and multiply in my missing factors to build to my denominator. The first one needs an x squared plus 16, and that bx plus c needs the x plus 3. Just multiplying in what's missing here. Now I just compare my numerators. So numerators, my numerator here is 6x squared plus 10x plus 51 is equal to, let's go ahead and multiply these through. So I've got ax squared plus 16a, that's this one. And then I'll go ahead and FOIL this guy. So we get plus b x squared plus cx, that's this one, plus 3bx plus 3c. Okay, so now we've got our highest degree is x squared. So let's go ahead and start working through these, comparing our coefficients. So I'm going to go ahead and start with my x squareds. I've got 6 of them on the left. X squared, I've got a, b, and that's all. So 6 equals a plus b. X's are next. I've got 10 of them. 10 equals x's, c plus 3b, c plus 3b. Constants are next. 51 is equal to 16a plus 3c. So I end up with a system of equations. I can go ahead and solve my system of equations, but I want to show you a really easy way to solve it so that you don't have to do this algebraically. I'm going to put it into a matrix. And if you're not familiar with matrices, that's okay, because I'm going to put it into a matrix in a very, very simple way. I'm going to give myself a column for my coefficients of a, b, and c. My equal sign is going to go here, and then my numbers, the constants on the other side, are going to go there. So I actually want to retool this guy. So I want a plus b, there is no c, equals 6. When we put this one into its row, I get 1, 1, 0 c's, 6 for my constant. Okay, so that's that one. Now for the x1, there are no a's, but I have 3b plus c equals 10. So 0 a's, 3 b's, 1 c equals 10. Finally, I've got 16 a's plus 3c equals 51. So 16, 0, 3 c's equal 51. I'm going to go ahead and put this into my calculator as a matrix. Let me grab my calculator. I'm going to put it in as a matrix. I'm going to go to second matrix. You could absolutely solve this using a system of equations and some algebra, but I wanted to show you how to do this. It's so nice. I'm going to go over to edit, and I'm just going to choose any letter. I'm just going to choose A. And it says, what size is your matrix? These are rows by columns. If you mess it up, that's okay. I've got 1, 2, 3 rows, and 1, 2, 3, 4 columns. I'll hit enter. You'll know that you're not right if your shape doesn't match the shape on your calculator. My shape matches. So if you messed it up, go ahead and just change your size, called your dimension. And I'm going to go ahead and put my coefficients in. So the first row is 1, 1, 0, 6. The second row is 0, 3, 1, 10. Third row is 16, 3, 16, 0, now 3, and then 51. Okay, I'm just going to double check. 1, 1, 0, 6, 0, 3, 1, 10, 16, 0, 3, 51. Okay, great. So I put that into matrix, and that was in the edit. I'm going to go quit here. I'm going to go back into matrix. I'm not going to go to edit this time. Now I want to do some math on it. So I'm going to go ahead and go over to math, and I want row reduced echelon form. This one, RREF. Let me make this a little bit smaller so you can see both things here. So I want to do oops, there we go. Okay, so now I want to do RREF of matrix A. So I choose RREF, I hit enter, and it says RREF of what? So I'm going to go back to my matrix menu. Now I'm going to go to names, and I just hit enter because my matrix is right there. I go ahead and hit enter. And it gives me this 1, 0, 0, 3, 0, 1, 0, 3, 0, 0, 0, 1. Remember what these represented. These represented each of my letters. A was the first column, B was the second column, and then C, then my equals, then my numbers. So I can rewrite each of these. So the first row says that I have 1A, nothing else, equals, so crossing over my equals the number 3. Second row tells me that 1B equals 3. Third row, and I miswrote that, didn't I? Third row, this should be a 1. 1, yep. So that one tells me that 1C equals 1. So I very easily, without having to do much more work other than multiplying my numerators out and getting my coefficients compared, I was able to let the calculator do the rest. So that's in your matrix menu. You're going to edit to plug your matrix values in, plug your coefficients in, and then you'd go into the math menu and look for that row reduced echelon form. So just a really, really cool way to solve this. We still need the answer though, right? So let me go ahead and put our answer up here. Our answer is, let's see, A was 3, and there's my first fraction. I'm going to write it here. So 3 over x plus 3 plus B was 3, 3x plus C was 1 over x squared plus 16. For those of you going on into calculus or into something like a finite math or something like that, matrices are really, really powerful. Just a really nice way to simplify a lot of algebraic solving.